So we want to solve 2 cot phi plus 35 is equal to 5 for values of phi in this range here. So that would be cot phi plus 35 degrees equals 5 over 2. And remember cot's 1 over tan. So we've got tan of phi plus 35 degrees would be 2/5. And we can certainly now get a principal value for phi plus 35 degrees. That's going to be the inverse tangent of 2/5. So now we're in degrees here. I need to change the calculator mode. So we need to be in degrees, and tan 0.4 and 21.80, we'll call that. Okay, now we're solving phi from 0 to 360. So if we're thinking about phi plus 35, we need to be solving that from 35 right the way round to 360 plus 35. So right the way round to 395. Okay, so we have got a tangent which is positive. 21.80 here. And if we go down there, that will be 21.80. But bear in mind, we're going from 35 around ones. So the 21.8 is not actually going to be part of our solution here to start with. So we're going to go around there, and that's 180 plus that. So that is going to be 5 plus 35 is going to be 201.80. And then we're going to keep going, and that will be 381.80, and then we run out of solutions. And then, so what we need to do is take 35 off of each of those. So we have got 201.8, take away 35, so 166.8. And then 381.8, take away 35, gives me 346.8. And then moving on, and finally for this paper, we want to show, actually there's two parts to this. So we want to show that this holds true. So let's start with the left hand side because there's just simply more there. So we've got sec theta over cot theta plus tan theta. Okay, so that's sec theta over cot is cos theta over sine theta, and tan theta is sine theta over cos theta. Now I don't want fractions, and in fact this sec theta of course is 1 over cos theta. So I'm going to multiply top and bottom by sine theta cos theta. Now if I do that, on the top I'm just going to end up with sine theta, which is a good sign. That's what we're trying to show. And on the bottom I'll end up with cos squared theta, because the sine will cancel and the cos times cos, and then I'll end up with sine squared theta. And I know that cos squared plus sine squared is 1, so that's sine theta over 1, which is sine theta, which is of course equal to the right hand side. So that worked out not too bad. Hence solve sec 3 theta over cot 3 theta plus tan 3 theta is negative root 3 over 2. Well, whether or not we were able to show this, we can replace the left-hand side of that with sine 3 theta. So sine 3 theta is going to be negative root 3 over 2. And we're going to be solving for 3 theta between negative 3 pi by 2 and 3 pi by 2. We'll worry about that in a moment. Our principal value, this is going to be a standard angle, but of course you've got your calculator anyway. 3 theta is going to be, so we know the sine of 60 degrees, or pi by 3 radians, is root 3 over 2. So it's going to be pi by 3. Okay, so let's use a cast diagram now. And so negative root 3 over 2, so negative pi by 3. So that would be down there, pi by 3. And if it's a sine and it's negative, the other one's in the tan, so that's pi by 3 down there. Now we're solving from negative 3 pi by 2, which is around here, around to 3 pi by 2, which would be down there, but we've got to go around once to get there. So if we're going around here, we're going to get this one first. So that one is at negative 2 pi by 3. Then we'll come and we'll get this one, which is at negative pi by 3. And then we're going to keep going. And we get to there, which is actually at 4 pi by 3. And then we get to the stop point. So we've just got those 3 solutions. So that's going to be negative 2 pi by 9, negative pi by 9, and 4 pi by 9.